This episode was translated from a German interview with AI.
So we're talking about hundreds of engines installed in large data centers.
We are the only company in the world that can coat the inner surfaces of bores from cylindrical geometry, that is from a tube as the starting material in the so-called coaxial geometry. Miba's unique selling point essentially lies in the diameter range, because we are also the only ones in the world who can coat diameters from 360 to 370 millimeters with very high precision, uniform coating thickness, and excellent coating properties.
Welcome to a new episode of Miba Inside, Miba's tech podcast for all Miba colleagues and for everyone who is passionate about technologies for a cleaner planet. Here we talk about what you don't normally see. The technology inside engines, trains, ships, wind turbines, hydroelectric power stations, power grids, and much more. Our experts from Miba explain how our components help make our customers' products and applications safer, more reliable, and more energy efficient. And they'll also show why we're among the world leaders in many of these specialist fields. Today we're discussing how specially coated Miba hydrodynamic bearings help to supply data centers with power in a particularly reliable and fail-safe manner. A little spoiler. The hydrodynamic bearings are installed in high-load motors, so-called high-POW motors, short for high power, and in emergency power generators. My guests today are from the Miba Engine Bearings Group, namely Hans Nagl, who is Technical Manager for the development of sputtering processes at the Technology Competence Center of Miba Engine Bearings, and Michael Putz, who is Key Account Manager at Miba Engine Bearings, the hydrodynamic bearings division for engines. And both are based at Miba Gleitlager Austria in Lackirchen. A very warm welcome. It's great to have you here.
Hello.
Hello.
To start with, I'd like to ask you to introduce yourselves briefly so we can get to know you better. How long have you been with Miba, and what brought you here, Michael?
I've been with Miba for over 20 years, almost 30, and have worked in various departments. I started in the special machine construction area at Miba Automation Systems, MAS. A few years later, I moved to an application engineering role, spent 2 exciting years at our Miba McConnellsville site in the US. Since 2010, I have been working as a key account manager in the front office at the bearings division in Lackirchen. Here, I'm responsible for our major customers in the high-performance engine sector.
And you, Hans?
I started my 19th year at Miba at the beginning of this month. I come from a background in experimental physics, but decided it was all too abstract for me and then found a job advertisement from Miba on the notice board next to the dean's office. They were looking for someone with expertise in vacuum technology, and that was my ticket to Miba. Since then, I've been working on coating technology.
So you went straight from uni to Miba?
Exactly.
What's actually the best thing about your work for you personally?
It's the independent work. Working together with our customers, bringing the customer's perspective and their problems into the company, and then finding a solution together with the team. It's a really exciting job.
Hans, what about you?
The best thing is that it never gets boring, juggling technological challenges with what the customers need and what the operations side, production and quality requires. And of course, what's also a lot of fun is working in a team where everyone puts their heart and soul into it, where we work in a multidisciplinary way. And as is often the case in our development department, I like to call it the critical mass that is reached when enough people with the right skills and talents come together. In the end, the result is simply greater than the sum of its parts.
Today we're talking about hydrodynamic bearings, which undergo a very special treatment, a special coating applied using a process known as sputtering. That sounds very technical. How can you explain it in simple terms? What sort of technology is it and what does it achieve, Hans?
In the sputtering process, a piece of metal is vaporized using an electrically charged gas known as plasma. It's actually broken down into its constituent parts, and this vapor is then deposited atom by atom onto the component to be coated. This process allows us to significantly influence the material properties. The base material is then transformed into a very fine-grained material that is significantly harder and more wear-resistant than the original material. And we use this to make our components stronger, more robust, and longer-lasting.
Which is very important, especially for engines. That sounds like an extremely sophisticated technology. Can anyone do that, or is Miba the only one capable of doing it in this way?
The technology itself is very widespread, but the way Miba Gleitlager applies it is very specialized. In other words, our process is tailor-made for coating hydrodynamic bearings We are the only company in the world that can coat the inner diameter, that is the inner bore surfaces, based on the cylinder geometry, starting from a tube as the raw material in a coaxial geometry. Miba's unique selling point essentially lies in the diameter range. On the one hand, we are able to coat bore diameters up to 60 millimeters, and at the upper end, we are also the only company in the world that can coat diameters from 360 to 370 millimeters with very high precision, uniform coating thickness, and excellent coating properties. And that is precisely the diameter range relevant to the application we'll be discussing in more detail later today.
So, world-class high-tech. You're the only ones who can coat the inside of hydrodynamic bearings like that. How did you develop it? How long does it actually take to develop such a specialized technology?
Technology development at Miba began long before my time. Development started in 1983, but if you go back even further, this sputtering process was first used industrially in the 1950s and 1960s for optical coatings and tool coatings, and it was then when engineers found out that the coatings produced using this process were superior to those from conventional methods. Up until that point, electroplating was state-of-the-art in hydrodynamic bearing technology. However, the potential was recognized, the technology was brought to Miba, and through perseverance, it was successfully developed to the point where it became a commercially viable process. And the first sputter-coated bearing, which went into series production in 1988, was then one of the enablers for engine manufacturers to achieve higher power densities in smaller installation spaces and to be able to build higher charged engines in the first place.
So a real game changer, actually.
Exactly. That was a game changer back then, and since then we've kept pushing, further developing the process, the products and the materials, and then I think it was around 2008 we launched the next game changer onto the market, and that was the Sputter Syntec bearing, where a polymer layer was applied on top of the sputtered layer. The sputter bearing has major advantages when it comes to fatigue strength and wear resistance. However, when developing materials for hydrodynamic bearings, you always have to make compromises. That means that if you have a material that is very strong and highly wear resistant, you sacrifice flexibility, robustness, and adaptability. To make the strong, wear resistant sputter bearing more robust, we opted for a sandwich approach and applied an additional layer. By adding this extra material, we increase the adaptability of the hydrodynamic bearing and at the same time achieve very good performance in the mixed friction range. For example, during start-stop operation or if we experience a brief shortage of oil.
So these examples are exactly where the engines are subjected to the most extreme stresses, like rapid startup, rapid shutdown, or a lack of oil. That's exactly where this Syntec running-in layer helps ensure the hydrodynamic bearings continue to do what they're supposed to do.
Exactly.
Let's now turn to today's topic, hydrodynamic bearings in high-power motors and emergency power generators in data centers. The world needs more and more energy, not just because of AI, but also because of big data, edge computing, the Internet of Things, and so on. And data center operators want, or rather need, to be independent of external power grids. How exactly are these high-power motors, the hypo motors used in data centers, deployed?
The high-speed engines cover an electric power output range from roughly 500 kilowatts up to about 10 megawatts, just to put that into perspective. And they are used in all kinds of applications. For example, in earth-moving equipment, mining vehicles, and in the oil and gas sector, where they drive compressors, and of course they also play an important role in the power generation. And in power generation, these engines can run continuously as a baseload, they can cover peak demands, and they're also used for emergency power. That's especially important for data centers because they simply can't afford to lose power, not even for a moment. It's crucial that these systems are completely self-sufficient. So if there's ever an issue with the main power supply, the backup engines can immediately step in and deliver the energy that's needed to keep the system running.
Data centers can then be completely independent of the main grid if they use these high-power engines and, of course, emergency generators as a backup.
Exactly. And data centers are built with triple redundancy. That means there are 3 identical sites, and each of them has to be at least 200 kilometers apart. They're completely self-sufficient as well. They have to generate their own power supply. And interestingly, the data isn't stored on hard drives, but directly in RAM. That means the power must not go out at any time. So these facilities need enough emergency generators to back everything up. And we're not talking about just 1 or 2. We're talking 40, 50, even 60 backup gensets dedicated solely to that purpose.
which produce up to 10 megawatts.
In this case, they have around 3 to 5 megawatts each genset and of course can go up to 10 megawatts. In addition to the backup generators, data centers also need continuously operating gensets that supply power around the clock, delivering up to about 10 megawatts per unit. And in some cases, they'll even rely on turbines, which can provide 20, 30, or even more megawatts.
So that means there are up to 100 high-power engines in a data center and 40 to 60 emergency generators.
That's right. In a large data center, we're talking about hundreds of engines installed on site.
How big are these engines in terms of dimensions?
A 3 to 5 megawatt engine is approximately 10 to 15 meters long. I'd say a complete genset has the size of a large shipping container.
Wow, so basically a huge array of engines located at a data center.
Exactly. A 5 megawatt genset just barely fits on a large semi-truck.
So that means there are actually quite a few hydrodynamic bearings in a motor park like that at a data center. And logically, they all have to be working. How is that maintained? Because, as you say, the power has to keep flowing. That means the hydrodynamic bearings have to be running all the time too. How can you ensure that, and what advantage do Miba hydrodynamic bearings offer in this case?
Basically, with so many engines on site, not all of them are used at the same time. That means there's always a certain percentage of engines that can be taken offline for servicing and repairs. They're also regularly tested to make sure they'll perform reliably when they're needed. And the big advantage for our customers is the significantly longer service life of these engines, especially when they're running under continuous load 24/7. In that case, service life can reach 40,000 hours and beyond. And we're also talking about more than 6,000 starts and stops. That is extremely impressive and clearly puts us steps ahead of other available technologies in the market.
What kind of stresses are placed on a plain bearing in an emergency generator when it has to start up immediately?
In that case, the engine has to reach full load very, very quickly. Depending on the engine size, it has to ramp up to full load in under a minute. And that's exactly where the challenge for hydrodynamic bearings comes in.
What sort of forces are at work there?
It's roughly comparable to the force that 10 Formula One cars can generate at full throttle.
Impressive. And can this technology only be applied to hydrodynamic bearings or to other components as well?
Its application to hydrodynamic bearings is definitely a niche application. The process originates from optics or tool coating, and these are still very large markets today. Tool coatings produced using sputtering make them more wear-resistant. Anti-reflective or reflective coatings on glass or mirrors are also manufactured in this way. And of course, another very large market is the whole field of semiconductor technology. Sputter coatings can be found in every mobile phone and every electronic device. So in reality, this is an incredibly versatile technology.
But are sputter-coated hydrodynamic bearings only available from Miba?
The competition is trying to make them, but they have significant disadvantages. They have to buy the equipment. Miba can design, build, specify, and operate the coating systems itself. We're also able to manufacture the raw materials we use for the coatings ourselves, which our competitors can't do, and the entire process development and process technology too. All our competitors rely on external sources and on buying in know-how, whereas Miba is virtually self-sufficient in this area.
And how does it work when you sell a plain bearing? Manufacturers of engines or emergency generators probably don't just order an off-the-shelf product from you and have it delivered. It likely works differently.
Exactly. We're partners right from the engine development phase. These engines are designed for very specific applications, and we're involved from the very beginning, starting with the product design, including the dimensions and material composition. We carry out the calculations, design the bearings, run installation trials, and support our customers throughout the entire development process. And once that's completed, we verify whether the required service life has been achieved, supporting with our analysis and investigations. It's a process that takes several years.
So they come to you and say, we'd like to have your component in there. This is how we envisage the engine. And then you work together to develop the optimal product.
Ideally, we're given a small design space, and then it's up to us to make the best possible use of that space and still meet all the requirements with our components.
So it's actually a very close customer relationship. As we've already mentioned, the hydrodynamic bearings must demonstrate extremely high reliability. How can you ensure that before they even reach the customer?
Yes, it is. You're referring to the entire manufacturing process. It's absolutely essential for our products that all manufacturing processes are verified and reliable, so we can maintain and guarantee the high level of quality that's required.
In the early stages, so during technology and product development, we naturally use test benches to make sure that, on the one hand, performance, load-bearing capacity, and fatigue strength are right, that the products don't show any major variations, and that we can then move into the field and into application with a high degree of certainty and minimal risk.
For example, we copy the real engine operating conditions on our test benches, and this allows us to develop our materials exactly to the application demands.
Are there any other Miba applications where sputtering technology has proven its worth? Or do you already have further plans regarding the direction in which you want the coating technology to develop?
Sputter coatings in these products are, of course, used in other engine applications as well. We actually started introducing these coatings in the heavy-duty truck engines, and from there we expanded into high-speed engines, which is currently the biggest market, and then even larger engine platforms. Marine engines, for example, also use sputter solutions as well.
Not to forget our sputter coating for gearbox applications in aircraft engines, where we've been able to contribute an enabling technology that has significantly reduced noise emissions and fuel consumption.
And do these hydrodynamic bearings actually care how they're powered? I mean, whether it's gas, kerosene, diesel, or other fuels?
That's actually a field of research that a few colleagues are currently working on. In fact, it does matter to the hydrodynamic bearings. If we want to move away from fossil fuels and towards ammonia, hydrogen, and biodiesel powertrains, all these fuels produce different combustion products, which interact differently with our materials and can lead to varying degrees of corrosion. When hydrogen is burned, for example, a great deal of water is produced, and water in the engine can, of course, become problematic. And to understand these interactions and tailor our products so that we remain the technology leader with clean fuels in the future, we naturally have to look into what these interactions look like now.
Miba is a company with global locations. When it comes to engine bearings, for example, there are sites in the USA, China, and, of course, Austria. How does the collaboration work there? Can they all handle this sputtering technology? And how do you work with them?
All our manufacturing sites are equipped with sputtering technology and sputtering machines. These machines are actually built here in Austria by MAS, and from there, the technology is applied locally at each site.
So by Miba Automation Systems, which is also a Miba subsidiary. If anyone is listening to us now and is really interested in this technology and what you do, what advice would you give that person? How can they find out more about you, the technology, or your team?
Well, of course, it's never a mistake to study physics. I can only advise everyone to do that. But joking aside, if you want to find out a bit about our technology and development at Miba through official channels, there are regular events like the Long Night of Research and the Long Night of Industrial Culture, where we always try to actively present current research areas and priorities. You can also apply to us for internships, for bachelor's theses and for master's theses. There are always exciting little projects and activities where we need support and are always happy to hear from motivated applicants.
Do you have to be a university graduate or be finishing your degree to work at Miba or to work in your field with your technology?
No, you don't have to. There's also the apprenticeship for surface technicians, where we place a clear emphasis on the coating technologies used at Miba.
Besides going to college, you can also start an apprenticeship at Miba, and that offers you access to this coating technology in the bearing division. It really opens up many opportunities to get involved in these areas, and you certainly won't get bored.
Thank you both very much for this fascinating interview. It's been lovely having you here.
Thanks for having us.
Thank you.
Together we're creating technologies for a cleaner planet. Thank you very much for listening. Feel free to follow this podcast on your platform of choice. Until the next episode, take care.
This podcast is produced by Sputtered.